I want to start my presentation with the famous quotation of Benjamin Franklin. Once he said, "When the well is dry, then we will know the worth of water." He was absolutely right. According to World Health Organization, 2.1 billion people don't have access to clean drinking water, and 1.2 million people die every year due to unsafe drinking water. Although we are living in an industrialized world, but the amount of wastewater produced from industrial and agriculture sector is about 1500 cubic kilometers, which is 6 times more water than available in all rivers of our planet. Alone, arsenic has nearly affected 140 million people in 70 countries of our globe. If we just talk about Canadian manufacturing industries, they are producing 27 billion cubic meter of wastewater every year, which is equal to the amount of water being consumed by residents of two major cities of Alberta, Calgary and Edmonton. Because of the industrial activities, it has major impact on the water quality of the poultry industry to feed their birds. Poultry industries are using either surface water, water from the wells, or the dugout water to feed their birds. However, depending upon the location of the poultry industry, there are the potential contaminants in the water such as metals and organics. And because of these contaminants, there are many reports published where birds have neurotoxic or carcinogenic issues. However, by improving the quality of the water, we can get rid of the excessive amount of usage of antibiotic and can increase the profit for the poultry industry. The currently available technologies for the water treatment are reverse osmosis, activated carbon, silica, chlorination, or the oxides. However, these technologies are not viable for the poultry industry because they have a low absorption capacity, very expensive, short life, and they have poor desorption or reusability. So we need a solution that should be cheaper, environmentally friendly, and can be implemented on a larger scale. Here comes my research project to decontaminate the water using chicken feathers. Now you may be curious to know why specifically the chicken feathers. Chicken feathers are the poultry byproduct which are either landfilled or burned and creates environmental pollution. Also, millions of tons of chicken feathers are produced in Canada and around the globe. However, we can use them for a productive purposes. The main objective of my project to develop adsorbent, which is environmentally friendly in nature and have the ability to remove organics and inorganics simultaneously, and then the optimization to scale up these treatments, and most importantly to provide an alternative which is economically viable for the poultry industry as well as the other processing industries. Now comes the question how we can treat the water using chicken feathers. We did proximate analysis. Chicken feathers have mainly keratin proteins, about 92%. Keratin proteins have mainly disulfide linkage. By breaking these crosslinks, we can increase the surface affinity of the keratin proteins so that they can easily capture and essentially stick to a variety of toxic contaminants, including heavy metals. To develop this adsorbent, we introduced nanoparticle that is called graphene oxide. We introduced graphene oxide because it can be prepared from cheap raw material that is graphite. It has good functional groups such as carboxylic acid, alcoholic or the epoxide. It has good water dispersibility, large surface area, and most importantly, inherent ability of antibacterial. So, in order to develop this adsorbent, first of all, we did dissolution of the chicken feathers. Chicken feathers were first washed, ground, and then treated with hexane to remove the lipids. After that, it was treated with the reducing agent, and the pH was used 9.75 to dissolve these keratin proteins. These keratin proteins were further treated with the graphene oxide dispersion in water 1, 3, and 5% with respect to the weight of the dissolved keratin. After that, this mixture was sonicated and heated 90 degrees centigrade for 2 hours. Then this mixture was dialyzed, dried, ground, and sieved to get the adsorbent. After the preparation of the adsorbent, this adsorbent was characterized using different techniques such as FTIR, ATR. The FTIR, ATR was used to see the structural changes in the adsorbent after introducing graphene oxide. As this peak shows that there are 3 major differences in the amide 1, amide 2, and amide 3 regions, and also as stretching in the case of adsorbent have increased. It means the interaction between graphene oxide and chicken feather keratin protein have been introduced. So this claim was further corroborated using XRD analysis. XRD analysis was basically used to see the structural changes with respect to the crystallinity pattern of the adsorbent after introducing graphene oxide. The 2 main peaks are either reduced or disappeared. And also there is appearance of the new crystallinity pins, which mentioned in the mark region. It means the interaction have been produced or the generated between chicken feather keratin protein and the graphene oxide. So that can play a role for the absorption of the contaminants such as heavy metals. Furthermore, surface characterization was performed with scanning electron microscopy. The scanning electron microscopy of the neat chicken feathers showed that it has long, shaft, and smooth surface, while in case of absorbent, its surface turned into rough, and also it has shiny patches, which shows the presence of the graphene oxide on the surface of the keratin proteins. Furthermore, transmission electron microscopy was performed to see the changes in the internal structure of the keratin proteins that shows the presence of the graphene oxide in the polymer matrix of the keratin protein. After the successful synthesis of the adsorbent, we performed ICP-MS to see the adsorption capacity of this adsorbent. For this purpose, we took milk water and then that water spiked with the metals up to 500 microgram per liter and the pH was shifted to 7.5. After that, we added 0.1 gram of adsorbent for each metal and then incubated it, at the end centrifuge it and analyzed with the ICP-MS. This graph shows the adsorption capacity or the removal efficiency of the metals by using these adsorbents. Our adsorbent have better removal efficiency as compared to the neat chicken feathers as well as graphene oxide. These are the 1%, 3% and 5% adsorption capacity. So our adsorbent showed maximum adsorption capacity for the nickel, arsenic and the selenium. From all these results, we concluded that this low cost, high absorption, environmental friendly adsorbent have ability to replace the existing treatments for water decontamination. And then our adsorbent also have the good removal efficiency. And most importantly, it can provide an alternate for the waste management of the poultry industry related to the chicken feathers. And in the future, I would like to further modify these adsorbent and then the scaling up of this technology at an industrial scale, and most importantly, to use these adsorbent for the removal of inorganic and organic simultaneously. At the end, I would like to say thanks to my supervisors and all lab mates as well as the funding agencies. Thanks for listening me. If you have any question, you can email me and also you can ask any question during the live session.
Very nice presentation, Mohammed. Thanks. So a question coming through is chicken feathers already used in the industry and what are the uses?
So mainly the chicken feathers, whatever poultry industry are producing, they just dump them. And also there are some studies that I went through. I think they are using for the animal feed in some part of the Europe, I think. But mainly these are disposed of.
Okay. Another question, how do you see the implementation of your system in the farm, or do you see it implemented at the farm level? And does it act on removing pathogens?
Okay, well, so there are two possibilities because the poultry industry is not as large as the oil and gas and the other industries. So so far we haven't implemented in it. We are just working on the lab scale. And secondly, does it act on removing pathogens? Yeah. So our main objective is like organic removal of inorganic, but we are also thinking about the removal of the pathogens, particularly Salmonella enterica. That's also a part of my study, but so far we haven't done anything on that. But we are planning to use LED, light emitting diode technique to remove the pathogens along with the organic and inorganics.
Interesting. So if you're successful and you use these chicken feather products as adsorbents, and you can remove heavy metals, for example, from wastewater, what do you do with the material that's left over? Now you can, I think you said you could recycle the adsorbent, but what do you do with the heavy metals that are left over? And does that cause a problem?
Yeah, that's a very good question. So firstly, the keratin proteins are biodegradable in nature. So we are also planning to do the biodegradable studies for the proteins. As far as the heavy metals, so like some of the metals, they are used in the industry. If we able to produce like heavy metals or other metals on a larger scale, then definitely we will sell to the industries.
Okay, great. And one last question. Have you looked at water hardness effect in poultry production. So could you pull, for example, calcium out of drinking water?
I believe our absorbent can absorb these calcium or the sodium, but we haven't done any study on the removal of the calcium or the sodium so far.
Okay. All right. Well, we're out of time. Thank you very much for your excellent presentation.